Hi, this video is about activity Chem redemption under topic chapter 11 amine. So let's start. So based on here, right, you notice, right, total mark for this activity is 18. Let's check one by one. Okay, so part A, give IUPAC name and draw the structure for the following amine. So what is the name of this structure? So first of all, right, we know this is amine. Okay, and then there are 3 alkyl group. So the longest one is this one. So the longest one is this one with 4 carbon. Okay, so this is C1, C2, C3, C4. So the parent change is 2-butane amine. Okay, and then there are 2 alkyl group, and then the alkyl group, right, is the same alkyl group, so it's NN dimethyl 2-butane amine. Okay, and then let's draw the structure. This one also butane amine, but is 1-butane amine, meaning that the parent chain should be like this: CH3, CH2, CH2, and then this C, right? Okay, will attach with amine. Okay, so 1 carbon. Okay, here another 2 is hydrogen, hydrogen. Okay, you can write down CH2. Okay, straight away write down CH2. Okay, CH2. Okay, CH2. Okay, and so there are another 2 alkyl group, which is methyl and ethyl. Methyl is CH3, and then ethyl is CH2, CH3. Okay, so this is N-ethyl, N-methyl, and then 1-butane amine. So this one is 2-butane amine. The parent chain is 2-butane amine. So N-dimethyl 2-butane amine. So okay, the marks given here is 1, 1. Okay, next. Okay, next is about part B. State whether the statement is true or false. Let's check one by one. Amine has lower boiling point than alcohol of similar relative molecular mass because of weaker hydrogen bond, because N is less electronegative than oxygen. The answer is true. Okay, if you're not sure, right, actually you can check from your lecture notes. Okay, about boiling. This one is about what? This is about boiling point. Okay, but this boiling point is different compound. This boiling point is different compound. Let's check. Alkene, haloalkene, amine. Okay, if you compare alkene, haloalkene, amine, right? Because amine has hydrogen bond, that's why sure has strong, higher boiling point compared to haloalkene, alkene. But if you check, compare with alcohol and carboxylic acid, okay, and then amine is weaker. The hydrogen bond of amine is weaker than the hydrogen bond in alcohol and carboxylic acid because it's less electronegative. So this one is an explanation, right? This explanation is same as the question. Okay, so this is the explanation for our question. 1. Amine has lower boiling point than alcohol of similar relative mass because, okay, always remember, it has weaker hydrogen bond. Why? Because nitrogen is less electronegative than oxygen. We have to always remember the most electronegative is fluorine, followed by oxygen, and then the less electronegative is nitrogen. Only the hydrogen atom attached with FON, fluorine atom, oxygen atom, and nitrogen atom that can form hydrogen bond. Okay, next. Primary amine is the least soluble compared to secondary and tertiary amine. Of course, no. Primary amine is the most soluble one. Okay, this is about solubility. Let's check. Yeah, okay. All amine, including tertiary amine, okay, are able to form hydrogen bond with water. Okay, so generally, right, it is water soluble. But if you compare, right, among these three, okay, primary amine is the most soluble one. Why? Because it can form more hydrogen bond compared to the secondary and tertiary amine. So this statement, primary amine least soluble, is false. Okay, false. Okay, next. This one is okay about boiling point as well, but is different class of amine. Let's check N-methyl 18-amine. So this is secondary. Okay, 1-propene amine is primary amine. And N-dimethyl, there is 2 alkyl groups, so this is tertiary amine. So if we check, right, about the boiling point, by right, primary is the highest boiling point. Primary amine has the highest boiling point. Okay, let's check. Okay, the class. Okay, here. Yeah. If we want to compare different classes of amine, right? Primary amine has the highest boiling point, followed by secondary and then tertiary amine. Okay, always remember tertiary amine cannot form hydrogen bond to each other. That's why it only has weak van der Waals forces. Primary and secondary, yes, can form hydrogen bond, but primary amine form more hydrogen bond. That's why it has the highest boiling point. So that's why this statement is false. So by right, this is one propane amine has the strongest one. Okay, one propane amine has the strongest one. Okay, followed by this one N-methyl 18 amine, and then the weakest one is this one. If the question asks about increasing boiling point, right? So meaning that okay, suppose is N dimethyl methane amine. Okay, by amine has the lowest boiling point, followed by N methyl, okay, 18 amine, and then the stronger one is 1 propane amine. Okay, let's check for question number 4. Tertiary amine has the lowest boiling point. Yep. Okay, because just now we know already tertiary amine has the lowest boiling point compared to secondary and primary amine, because it's only can form intermolecular hydrogen bond. Okay, so initially, right, I just look at the first statement. Tertiary amine has the lowest boiling point. Yeah, correct. But because it can only form one intermolecular hydrogen bond, so the answer should be false. Okay, the reason not correct. Okay, so this answer right is false. Why? Okay, we check one more time, because we know, right? Okay, tertiary amine cannot form hydrogen bond, okay, to each other. So tertiary amine has only weak van der Waals forces. Okay, it's polar, so dipole forces between molecule. Okay, yeah, it has the lowest boiling point. For sure, it has the lowest boiling point, we know. But the reason is not due to it can form only one hydrogen bond, but it only can form weak van der Waals forces. So please take note. So tertiary amine has the lowest boiling point. This statement is correct, but the reason, right, because it only can form weak van der Waals forces, not due to it can only form one intermolecular hydrogen bond. Please take note. So the answer is false. Hati-hati ya. Okay, next part C. Drag and drop the product form for each reaction. Okay, since madam cannot drag and drop, right, I label this is question 1, question 2, question 3, question 4, and question 5. So we check for these choices, right? Which one is the answer for question 1? So this is haloalkane react with ammonia, meaning that this is nucleophilic substitution. Okay, so substitute. Okay, 1 carbon, 2 carbon. Okay, so this is the answer for 1. Okay, CH3, CH2, and H2. Okay, next. This is nitro compound, right? Zinc. Okay, this one is chemical reaction. This is chemical reaction. So you can refer to a lecture notes. Which part? Okay, go to basicity. Wait, yeah, here, I think here. Yeah, this is nitro compound. You see? Nitrobenzene. Okay, this is nitrobenzene. Okay, and then react with acidified zinc. Okay, acidified zinc. Okay, not only acidified zinc, can be stannum zinc or iron, stannum chloride zinc or iron chloride zinc. It form, oh sorry, not iron chloride, it's iron. Iron. Okay, these three reagent. Okay, actually is undergo reduction. So reduction of nitro compound form aniline. Okay, so the answer, right? Okay, question number 2. The answer for question number 2 is this one. Yeah. Okay, next. Hydrogen PT actually also one of the reducing agent. So there are how many carbon? 1 carbon, 2 carbon, 3 carbon, 4 carbon. Okay, it's a nitrile compound. What happened? So let's check for C double bond N, C triple bond N. Yeah, okay, nitrile compound reduced to primary aliphatic amine. So this one becomes CH2 and H2. Okay, the number of carbons still the same. So we have to just copy the R group, and then here, right, the C will become H2 and will become NH2. Okay, so simple, right? Okay, let's check for the answer. Okay, let's check for the answer. Okay, so the answer is 4 carbon and then CH2 and H2. Yeah, this is the answer for question number. Hey, be careful. Here, this one is 4 carbon, this one is 3 carbon. So if 4 carbon or 3 carbon, double check. Okay, always double check. Okay, 1, 2, 3, 4, 4 carbon. So this is the answer for question 3. Just now, this one is question 2, question 3. Okay, next question 4. This is actually is nucleophilic substitution as well. Yeah. Okay. Actually, this is haloalkene. If you notice, right, actually this is haloalkene. So haloalkene, right, the Cl, okay, will eliminate, okay, we'll substitute it, okay, by the end. So eliminate HCl. So here I will attach CH3. So it forms tertiary amine. So check which one is the answer. Yeah, this is the answer. Okay, it forms tertiary amine. So this is a tertiary amine. So this is the answer for question number 4. And then the last one, okay, bromine, sodium hydroxide, water. Okay, what is this reaction? Okay, this is Hoffman degradation, right? Is it? Yeah. Okay, this one, Hoffman degradation of primary amide. So this one, right, the C double bond O will eliminate. Okay, so terus hilang C double bond O hilang. So meaning that the number of carbon will reduce 1. So initially here there are 1 carbon, 2 carbon, 3 carbon, 4 carbon. So eliminate C double bond O become 3 carbon compound. So the answer for question number 5 is this one. Okay, I hope you all can get to get the correct answer. So there are 5 marks for this part. Okay, just now 4. Okay, part 1 2, part B 4, part C 5. Okay, let's continue with part D. Part D, there are 3 marks. Suggest a chemical test to differentiate between aniline and 1-butene-amine. Aniline. Okay, based on this, right, okay, always remember the format to answer the question for chemical test, right? Make sure you write down the name of the test, the reagent, and then write down the equation, and then the observation. Okay, same thing for the second compound. So this is another equation for another compound, and then observation. Okay, reagent and condition. So chemical test reaction with nitrous acid. If you check for nitrous acid, okay, let's check for nitrous acid. Okay. Here all about the synthetic. Okay, here about chemical properties of amine. So nitrous acid test. We can distinguish classes of amine by using these 2 tests. Okay, and then explain the identification test of aniline using bromine water. Okay, aniline we can specially use aniline bromine water. Please take the aniline we can use bromine water. Explain the formation. Okay, of dye by the coupling reaction of benzene diazonium chloride. Okay, for information, this is a very popular question because if you check the past year question, right, there were many questions related with benzene diazonium chloride and phenol, which can form dye. Okay, and they outline the synthesis of compound related to reaction of amine. So we look at a nitrous acid test because the question is related with nitrous acid test. Yeah. Okay, nitrous acid is a weak and unstable acid. Always prepared in situ. What means by in situ? Means treating the cold sodium nitrate with an aqueous solution of a cold dilute hydrochloric acid. So that's why when we write down the reagent, right, we have to write like this. Okay. Yeah, this one. NaNO2HCl, and then the condition is 0 to 5 degrees Celsius. Okay. So the first one, reagent. Okay. You have to write down NaNO2 HCl, and then the condition is CO2. Actually here, this is a hint already. Okay, here is a hint already. So what is the reagent? So you must write down. This one is NaNO2 and then HCl. Okay, and then the condition is 0 to 5 degrees Celsius. So when aniline react with nitrous acid reagent, right, what happened? Okay, you see no formation of gas bubble. But what is the product? Let's check. Okay, yeah, okay. It will form a benzene diazonium salt, and then the byproduct is sodium chloride and water. So the main thing is this one, benzene diazonium salt. Benzene diazonium salt. So the answer is benzene diazonium salt. Okay, for easier for you all to do revision, right? You just write down the name, benzene diazonium salt. Okay, azonium salt. Okay, double check the spelling. Make sure you write down the positive on the nitrogen atom and negative on the chlorine atom. Benzene diazonium salt. Okay, only stable at 0 to 5 degrees Celsius. Make sure you write down the condition 0 to 5 degrees Celsius. Okay, the byproduct you just write down. Since you know the byproduct is sodium chloride and water, just write down. But the mark only will be given for this benzene diazonium salt. Okay, next. This one is primary amine. If primary amine, right, react with nitrous acid test, it will form alkene. Okay. And then this one is haloalkene. And then this one is alcohol. Okay. And nitrogen gas. So the observation, right? Okay. If primary amine, you check what is the observation. Okay. Here, this one is okay. Formation of gas bubbles. Formation of gas bubbles. So you just write down here. Okay. Formation of gas bubbles. Okay, the gas bubble actually is nitrogen gas. But since the question just asked you about observation, right, just write down the observation. Formation of gas bubbles. Okay, you can bracket N2 like lecture. Okay, now we proceed to the next question. So there are 3 marks. So 1 mark for the reagent and condition, 1 mark for the product, benzene diazoxime salt, another 1 mark is for the observation, formation of gas bubbles. Okay, next, preparation of amine. Okay, this one is Hoffman degradation process. Okay, so as we know, right, it will eliminate the C double bond O. So the rest just copy. So the hints given right here is 6 carbon. You check 1, 2, 3, 4, 5, 6. Yeah, correct. So the answer, you just copy everything and then eliminate the C double bond O. Okay, for this question. So what is this reaction? This reaction is Hoffman degradation. Okay, check. Where is it? Just now, madam just explained only. To eliminate the C double bond O. Yeah, here. So the name of the process is, no, is it? Yeah, Hoffman degradation of secondary amide. Yeah. So this is the answer. Okay, so this one is the answer. Okay, 4 marks like this, you get 1 mark. Hoffman degradation is the name of the reaction. So 1, 2, 3, 4, 5, 6. Yeah, this one is the answer. Okay, next. Okay, for this case, right, reduction of amide. Okay, amide using reducing agent followed by hydrolysis. Okay, and then it remains 7 carbon, meaning that for this case, right, okay, the C double bond, all right, will reduce, become CH2. Okay, normally, right, for this case, right, it will reduce, okay, become CH2 and like this. Okay, so we have to check what is the reagent. This one we have to check for the reagent. And then the product, right, I know already. Okay, is CH3, C, CH2, CH3 here. Okay, just copy. There is hydrogen, CH2, CH2, and then the C double bond O will become CH2 and H2. Okay, and then we check the number of carbon. 1, 2, 3, 4, 5, 6, 7. Yeah, 7C. Okay, reduction of amide using reducing agent followed by hydrolysis. Let's check. Okay, which one? Okay, yeah, okay, this one. Reducing and then followed by hydrolysis. Yeah. Okay, we can use lithium aluminum hydride. Okay, lithium aluminum hydride. Okay, reduction. Okay. Is there any other answer? I think no. Okay, yeah, we are using lithium aluminum hydride. So lithium aluminum hydride. Okay, and then H2O. How to write down the reagent? Please check. You double check how to write down. 1 Roman, 2 Roman, isn't it? Okay, no, because this one is amide. This one is nitrile compound. Nitrile compound is 1, 2. Okay, but for this one, okay, double check. Yeah, this one also 1, 2. Be careful. For amide, lithium aluminum hydride H2O. But for this case, right, this one is lithium aluminum hydride H3O plus. Okay, for the nitrile compound, we are using H3O plus. For amide H2O. So you must write down 1 Roman, 2 Roman. If without 1 Roman, 2 Roman, right, the answer is wrong. Okay, so this one is okay, you will get 1 mark. 1 mark. Make sure must be 1 Roman, 2 Roman. Okay, yeah, finish. So double check here 4. Okay, 5, 6, 7. Okay, 7 plus 5, 12. 12 plus 6, 12 plus 4, 16. Okay, 17, 18. Yeah, total 18. So you check X over 18. Hope everyone can score 18 over 18. Okay, that's all for this video discussion. Okay, see you all on next video. Bye.